This question, 9.25, says a solution containing 80 grams of potassium chloride in 200 grams of water at 50 degrees Celsius is cooled down to 20 degrees Celsius. And the first part of the question says, how many grams of potassium chloride remain in solution at 20 degrees Celsius? So basically, you're taking some solid potassium chloride. It's an ionic compound, so it's going to be a solid at room temperature. You take 80 grams, you weigh it out, and you put it into 200 grams of water, and you warm that up to 50 degrees Celsius. So once you've got it in solution at 50 degrees Celsius, you cool it down. And how many grams of potassium chloride are going to remain in that solution once it's been cooled down to 20 degrees Celsius? So in order to solve this problem, you need some information that is found in a table in the book. It's found on page 339 in the hard copy of the book, and what it says is, I'll write it down here, it says at 20 degrees Celsius, it says the solubility of potassium chloride is 34 grams in 100 grams of water. And then it says that at 50 degrees Celsius, when the temperature is 50 degrees Celsius, the solubility is 43 grams of potassium chloride in 100 grams of water. So that information is required in order to solve this problem. So at 20 degrees Celsius, when I cool my potassium chloride solution down to 20 degrees Celsius, I know that I have 34 grams, or I can have 34 grams of potassium chloride dissolved in 100 grams of water. So if I have 200 grams of water, so I'm going to put 200 grams of water at 20 degrees Celsius, I know that for every 100 grams of water, I should have put water here in my, I'll just fix that. So there. For every 100 grams of water at 20 degrees Celsius, I'll have 34 grams of potassium chloride dissolved. So I'll just put 34 grams of KCl. So if I do my dimensional analysis, I cancel out my units, so grams of water and grams of water. So it's basically multiplying the number 34 by 2. So I end up with 68 grams of potassium chloride. That's how much would still be in solution. So the answer to A is going to be 68 grams. That's how many grams of potassium chloride are going to still remain in solution. Where's the rest of it going to be? Well, the rest of it would be precipitated out of the solution or crystallized. So how many grams of solid potassium chloride crystallized after cooling? So crystallized just means that the solution was cooled slowly and the potassium chloride formed crystals. So the amount of solid that crystallized, well, if I started out with 80 grams, so 80 grams, 2 sig fig, so 80 decimal grams, and I have 68 grams in solution, I'm left over with a total of 12 grams that must have crystallized. So 12 grams solid. I'll just put solid instead of crystallized. There we go. So I'd be left over with 12 grams in that case. So again, this is a problem that you have to have this information in order to solve. If you don't have this information, there's no way really for you to be able to solve this problem.